Good afternoon, everyone. Today we're going to solve this equation where we have on the left-hand side three terms that are in exponential form and another term on the right side that's in exponential form. But what we have to do here on the left-hand side is notice that all three terms have a 2 to the power of x embedded inside of them, right? And since they all have a 2 to the power of x embedded inside of them, we can factor it out. And so what we get when we do that is if we factor out a 2 to the x, then knowing our exponent laws, when we multiply through by the same base, we can add exponents. That means that 2 to the x times 2 to the negative 1 would give us back our 2 to the x minus 1 term, right? Then 2 to the x times 1 would give us back the 2 to the x term, obviously enough. And last, 2 to the x times 2 squared, right? Add the exponents, gives us a 2 to the x plus 2. And then on the other side, we have 11 times, just to save ourselves a bit of work later on, I'm going to rewrite the square root of 2 as 2 to the power of 1/2, and we have that to the exponent of 2x minus 1. Now what we can do on the left-hand side is we can simplify this expression inside our brackets, right? So now we'll have 2 to the x times 2 to the negative 1 is 1 over 2, so that's 1/2 plus 1 plus 4 is equal to 11 times. Now, let's use our exponent laws to simplify this part. We have an exponent to an exponent, and so we multiply those exponents, right? And so we'll have 11 times 2 to the power of 1/2 times 2x minus 1, meaning to the power of x minus 1/2, right? Like so. And then if we go ahead and add these three terms, 1 plus 4 is 5, 5.5 in improper fractional form means we have 2 to the x times 11 over 2, right? And that's equal to 11 times 2 to the x minus 1/2, like so. And now we can go ahead and divide through by 11 halves, right? That'll cancel out. 11 halves, right? Now we're dividing by a fraction, so I won't go through the details, but remember, when we divide by a fraction, we can flip and multiply. That would cause the 11s to cancel out. And then we'd multiply by a factor of 2. And that means that now, on the left-hand side, we have our 2 to the x that we factored in the very beginning. And then on the right-hand side, we're going to have this 2 multiply this 2 to the x minus 1/2, right? And that means that we have 2 to the x is equal to, that's 2 to the 1, right? And so we have 2 to the power of 1, we're multiplying by the same base, which means we can add the exponents. And so we'll have 1 minus 1/2, that's 1/2. And so that's x plus 1/2. And now that we have the same base, we can equate the exponents, right? And so we get our linear equation, x is equal to x plus 1/2. And turns out I didn't think these numbers through. That's okay, you can still get the idea. If we subtract x on both sides, we end up with an equation that states that 0 is equal to 1/2, which is obviously not true. And so that means that our solution, no solutions exist, and so this equation has no solutions. My goodness, no solutions for x inside the set of real numbers, which is not the satisfying outcome that I was hoping for, but doesn't really matter. You get the idea. You can factor it out, use exponent laws, and solve the equation in that way. I hope that helps, and thanks for watching.